Alright, let's look at congruent and similar solids. Today you will identify congruent or similar solids. And today you will use properties of similar solids. What could that mean? I don't know. Okay, so let's look at this. So what is a similar solid? A similar solid is a 3D figure with the same shape but not necessarily the same size. So what I did here was this first one I made and then I copied and pasted it and shrank it. So I know these two are similar because they're the exact same shape. How would I know that without knowing that I built that like that? If the ratios are equal to the two solids, then they are similar. Okay, so what does that mean? Well, let's look at an example. But first off, let's talk about congruent solids. Whoops. Congruent solids are basically the same size, same shape. They're exactly the same in every sort of way. Maybe we look somewhat different, but basically we should be able to tell. Like if the heights, if you divide the heights or the lengths or similar corresponding measurements and you get an answer of 1, then you know they should be the same size, same shape. Corresponding angles should be congruent, corresponding edges should be congruent, everything should be congruent. Okay, so now let's look at an example. So we have an example here, and I want to see if they're similar, congruent, or neither. Neither? 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 No, not neither. Anyways, so let's look at the heights. The heights here, let's say 4 and 6. Left over right. Okay, you get an answer of 2/3. For the sides, I got 8 and 12, and I get an answer of 2/3. So both these are similar. Not only are they similar, but I could even say that there's a scale factor of 2/3. Well, we'll say here like this, 2/3. And the reason why that's important is because then that means any measurement from the first one, or from the second one to, like from here to here, is 2/3 of that. Okay. If I had decided to go new over old, then I probably would have flipped that over. But I'm not too big on those when you're trying to determine whether it's similar or congruent. Which one you put on top, which one you put on the bottom, what scale. I mean, I could take variable scaling factors. I might be a little different when we get to determining something else. Anyways, let's look at this one. So if I say these are the widths, then the widths I could say is 1.3 over 1.7, left over right, I can get 1.76. And if I say those are the heights, and there's a reason why I'm saying those are the heights, 6.2 to 3.4, I get 1.8. And then if I look at the lengths, I get 1.67. So none of these have the same ratio, so this one is a neither. It's neither similar, it's neither congruent, so it's neither. Now, if it had been congruent, it would have been 2.5, 2.5. It would have been 6.2, 6.2. It would have been 1.3 and 3 or something like that. Okay? All right, so that leads us to the next part. If we know that the things are, say, similar, then we can say that the scale factor is so on and so forth for a to b, a squared, b squared, a cubed, b cubed. So volumes is going to be that. So what does that mean? Okay, well, before we did something like this. If you had, I'm going to back this up just a wee bit. If you had new over old, and you were given the sides, this was important for the sides, and you said new over old squared, took that and squared it, and then said times the old area, you would get the new area. Well, now we're going to cube it. And if I multiply the volumes, I will be able to get the new volume. Okay? Similar idea here. If I have the areas, new over old, and I took the square root times the old side, I got the new side. Well, now if I got the volume, I need to take the cube root, and I will show you how to do that. And multiply the old side and get the new side. So how does that work? Okay, so I got to decide what's new and old. Remember, new is the one that's missing something. So I'm going to say this one is new. So this one kind of backwards what we normally do. And this one is old. So, and they're giving me the volumes here. So what does that mean? It means I'm going to go, okay, 270 over 640. And then I'm going to say cube root that. And basically, that if you type that in the calculator, you get 27 over 64. But you're going to cube root that. Okay, when you do that, you get 3/4. You would multiply 3/4 to 10, and that would give you this height, which should be 7.5. So the answer here for this height is 7.5. That's really all that is. And I'll show you how to, say, get the cube root and things like that, so that should be hopefully a little bit easier. But keep in mind, make sure you're paying attention. Are they talking about areas, or are they talking about volumes? And then you can kind of go from there, and that will decide what you need to work with. Anyways, I'm going to go ahead and stop there. I think that's pretty much all we need to do today. We'll talk about it, look about it more, and so on and so forth, and we are good. Thank you so much for your time. Y'all take care.